This is section 6.3, preview activity 2. So in this preview activity, we start off with a function, f from a to b. We have a statement for all x and y in a. If x is not equal to y, then f of x is not equal to f of y. So we're asked to find the contrapositive of the statement and the negation. So the contrapositive, you already saw in preview activity 1. So contrapositive is for all x and y in a, if x equal, no, if f of x equals f of y, then x equals y. Okay, now these are both the same statement. One of them is easier to work with. This one, it's really easier to work with things that are equal than things that are not equal. So I recommend the second contrapositive statement. Now negating the whole statement says, well, for all alternatives there exists x and y in a such that which one do I want to negate? There's equivalent ways to do it. So to negate an if-then is to say that if is true, but the then is false. F of x equals f of y, but x is not equal to y. Okay? So that's how you show. So this is you'll learn later on in this section as you read that this is a statement for being a function being injective. And so to show a function is injective, it's best to use this statement. To show a function is not injective, it's best to find two numbers such that this is true, two actual elements. Okay? All right, so number 2, now we deal with the surjective statement, which is for all y in b, there exists an x in a such that f of x equals y. All right, negation of the statement. Negation is there exists a y in b such that for all x in a, f of x is not equal to y. So that means you can find something in b that's not in the range. Okay, it's not in the range because for all x in a, f of x, that would be the range. And so if y is not equal to that, it's not in the range. Okay? All right, number 3, let g be defined by g of x equals 5x plus 3. All right, now pay attention here because you're going to be asked in this section to prove things are injective or surjective, and this gives you a good start for those types of proof. So first we're going to prove for part A, we're going to prove that it's injective, or sometimes called one-to-one. So we want to prove for all a and b in the real numbers. So like when you're doing your homework, you're like, I have no idea how to start. Look back to these ones. All right, so for all a and b in the real numbers, if g of a equals g of b, then a equals b. This is our claim. So proof. We let a and b be the real numbers and assume g of a equals g of b. Well, you can't see that. All right, I'm just rewriting what's already in the book though. G of a equals g of b. All right, this means a period. This means 5a plus 3 equals 5b plus 3. Okay, what did the book just do there? It assumed this, and then said, well, what does that mean? G of A is this. G of B is that. Then we do algebra. So subtract 3 from both sides, and you get 5A equals 5B. And divide by 5, you get A equals B. Thus, the claim is proven. Okay, sorry, you can't see that. So, thus the claim is proven. And then we're done. Okay, pretty easy. Proof of an injective function or a one-to-one function. Okay, and then the last part was for all B, in the real numbers, there exists as a claim. It's always good to kind of differentiate your claim from your proof. For all B in the real numbers, there exists an A in the real numbers such that G of A equals B. All right, proof. Let B be a real number. Okay, so we need to find A such that G of A equals B. So we need 5A equals 3. Okay, so here's where you can do scratch work. Let's do some scratch work outside the proof. So we're looking for 5A plus 3. We're looking for, let's go back up even more. Looking for G of A equals B. Okay, so now we're going to do algebra. Algebra helps us figure out what we're actually looking for. So if we're looking for G of A equals B, we're looking for 5A plus 3 equals B. Well, let's solve for A. So we're looking for 5A equals B minus 3. So we're looking for A equals B minus 3 over 5. Okay? So we don't have to show that in our proof. You don't have to show that. Sometimes it's fun to like have a proof where it comes out of nowhere. So now I say, consider A equals B minus 3 over 5. You might wonder, how did I get that? From my scratch work, starting with G of A equals B and solving for A. Okay, consider that, period. G of A equals, equals 5 times A plus 3, because that's what G does. Okay, but what's A? That's 5 times A minus 3 over 5 plus 3. 5 divided by 5 is, so A minus 3 plus 3 equals A. Thus, there exists an A in the real numbers such that G of A equals B. Now, something I could have added here is that A is also a real number because real numbers are closed under division and subtraction. But at this point, we all know that. Okay, now that we've hammered that in, so at this point, that's something you can kind of leave unstated if you like. You can also state it, that's also fine. But so we consider this, it is a real number because it's, arithmetic. And then look at that, G of A equals, oh, that's B. Bet that was confusing to you. Yeah, because A equals B minus 3 over 5, so I substitute. So over here I might say, my reasons, I might say definition, substitution, algebra, algebra. Okay? All right, that completes preview activity 2.